We are sharing two important questions on curve sketching in this particular video. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have a very interesting question which will help you understand curve sketching, an important point, concept on calculus. The question here is, the graph of y equals to f of x is shown. State the x values and or intervals where first derivative is 0, function is equal to 0, first derivative is greater than 0, first derivative is less than 0, second derivative is greater than 0, second derivative less than 0. So that's your first question to be done. We also have second question where we are given the graph of the derivative. So the other question is, graph of first derivative is given to you, y equals to f prime x as shown. So this is the graph of first derivative. And related questions are, where can be the point of inflection on f of x? Determine interval where f of x is increasing. Determine intervals where f of x is concave down. Determine values of x if it exists, where the graph has local minima. Determine value of x if it exists, where the graph has local maxima. Now these two type of questions where the graph of function is given to you and you have to find all other things, or when graph of first derivative is given to you, you have to relate it to different characteristics, are very important when we talk about curve sketching. Perfect. So in this video, we're going to discuss this at length. You can always pause the video, answer the question, and then look into my suggestions. In case you want to learn from me, you can always send an email on the address given. Most of my students are doing extremely well. Some are there on top of the class getting scholarships and awards like Akshat.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandilani.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Now, let us look into the solution of this particular question. Remember what we are given. We are given the graph of y equals to f of x, right? So this is the graph of the function itself, and we need to find all these things. So let's begin with first two questions where from the graph of the function we have to find where is the derivative equals to 0. So our focus is where is the derivative, first derivative is equal to 0. Now these points are also called stationary points, okay? The idea is while answering these questions, we need to understand the concepts, and that should help many students. So the derivative being 0 are called stationary points. If you look at this, all those points are the turning points, right? Do you see that? So these are the turning points. So for example, right there, correct? Horizontal tangent. So these are the points on this graph where we have first derivative as equal to 0. And therefore, now I can write this answer as at x values. So this is not an interval. This is a particular point. So starting from left, we have x equals to -1, which is right there. then x equals to 2, perfect, and then at x equals to 4, right? So at these points, we have horizontal tangents. That means gradient is 0 or first derivative is 0. Perfect. So we have answered the first question. Second one, where is the function value equal to 0? So function value equal to 0 means what? It means we are looking for x-intercepts, right? So clearly the x-intercepts are at x equals to minus 1.9, which is this point, right? X-intercept. The other two, rather 3, I've highlighted. So let's write down these values. Then we have 0.6, and then we have 3, and then we have the last one, 4.4. So those are the 4 x-intercepts highlighted in yellow, just shown. Perfect. So we got the second one. Let's move on and take the answer to question number 3, which is, where is the first derivative greater than 0? Now what does that mean? So when I say first derivative is greater than 0, it means what? It means the function f of x is increasing, right? So that becomes an interval. So the function is increasing from the minimum to this maximum and then from this minimum onwards, correct? So that gives you the interval from minus 1 to 2, correct? And from 4 to infinity. Make sense? So that is how we will answer question number 3. Perfect. Now let's take up question number 4, the decreasing interval. Correct. So let me write question number 4, where the derivative should be less than 0 means f of x is decreasing. So in the interval from minus infinity to minus 1, right? And from 2 to 4. So remember one thing, whenever you're looking at a graph, so you have to see from left to right. So when you see left to right, see this is decreasing, correct? Negative gradient, any point in this interval up to the turning point. That's what we mean. Perfect? Great. Let's take up question number 5, where we are not talking about the second derivative, right? So we did see the first derivative significance while we were working on increasing and decreasing interval. Now we'll focus on second derivative. So graph of this function is given. We need to find the values or intervals where second derivative is greater than 0. Now what does that mean? So question 5 is second derivative greater than 0. Well, if second derivative is greater than 0, the graph will be concave up, right? That is what it is. So concave up. So we see that the graph is concave up, like from here to there, right? So that is a point of inflection. So we can write down our first interval here from minus infinity to the point given to us is 0.2. And then it is concave up from 3 onwards, right? So you could include that. You can write union also, okay? And from 3 to infinity. So that is the interval when the second derivative is positive. Now when is it negative? Let's figure this out. Question 6. You can always pause the video, answer this particular question, right? It is the portion where it is concave down, and the interval which is left in between, right? And that is from 0.2 to 3. So that is how we can actually answer this particular question. So I hope with this, the concept of analyzing the given function is absolutely clear. Perfect. Now look here once again. First, we wanted to find the stationary points, which are the turning points, right? So stationary points were the turning points. And then we wanted to find the zeros. F of x is 0, which are these points, right? 4 of them. And then we wanted to find where is the derivative greater than 0. Means it is rising, right? So this is like increasing, correct? I should draw my arrow here, derivative increasing, correct? So it is increasing here. The function is increasing here, right? And of course, the left portion is decreasing. And then we have to focus on the portion which is about the concavity. Concavity, when it is greater than 0, then it is concave up, right? And that's the portion. Up to here and here. You get the idea? So that is how we should be answering this question. Perfect. So once again, these are your answers. You can match. And I hope that makes sense. In case you want to learn from me, you can always send an email and master curve sketching at least. Okay. Now let's take up the second question, which is kind of similar. But now we are going to analyze the first derivative. The question here is, graph of first derivative is given to you, y equals to f prime x, as shown. Cubic function. You have to answer these questions. Where can be the point of inflection on f of x? Second, determine the intervals where f of x is increasing. Third, determine the interval where f of x is concave down. Fourth, determine value of x, if it exists, where graph has local minimum. And fifth, determine value of x, if it exists, where graph has local maximum. So it is not necessary that these points may exist, okay? Perfect. Anyway, you can answer these questions, submit them in the comments. We'll provide you the solution in the next video. I hope you understand and appreciate these concepts. Feel free to share your comments and suggestions. If you like and subscribe to my videos, that will be great. Anytime, you can send an email on this address to learn from me. Thanks for your time and all the best.